Let's begin. Today's December 23rd, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria cards 2, 6, 9, 13, 16, and 22, and the puzzle uses the blue verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So on the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. Criteria card A takes a look at our first digit, the triangle digit, and the Turing Machine will be comparing it to the number 3. So should the value of triangle be less than 3? Should it be equal to 3? Or should the value of triangle be greater than 3? Criteria card B will take a look at our middle digit, the square digit, and the Turing Machine will let us know whether it's an even digit or an odd digit. Criteria card C will take a look at the 3-digit solution, and the Turing Machine will let us know how many 3s there are. Are there no 3s? Is there a single 3? Perhaps 2? Maybe even all 3 are 3. Criteria card D will take a look at our middle and last digits, square and circle, and compare them. So should the value of square be less than circle? Should they be equal? Or should the value of square be greater than circle? Criteria card E will take a look at our 3-digit solution, except this time it'll let us know a little bit about the ratio of even to odds. Should there be more even than odds? Or should there be less even than odds? And finally, criteria card F, again, we'll take a look at the 3-digit solution from triangle to square to circle, and will inform us a little bit about the ordering of the 3 digits. Should the 3 digits appear in an ascending order, meaning that they're increasing, as in the example 135, or could they be in a descending order, or decreasing, as in the example 421, or could they have no order? Let's take a look at the example of 231. Notice that it goes from 2 to 3, meaning it increases, and then it goes from 3 to 1, then decreases. Of course, you could have a code that is decreasing and then increasing, but basically it's that shift from one direction to the other that can define a 3-digit code as having no order. Now, we have seen other puzzles in the past where if you have consecutive equal digits, that can also exhibit no order. For instance, if we take a look at the example from criteria card C, the 331, notice that the 3s are consecutive, they're next to each other, and they are equal. So the reason I state that this is an example of no order, and that's because when you go from the first 3 to the second 3, there is no change. It neither increases nor decreases. So for that fact, digits that are, or solutions that exhibit consecutive equal digits have no order. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all the 6 criteria cards we just discussed. And we're going to start off with an initial proposal of 314. So the first thing I'd like to test is criteria card B. Okay, so the Turing Machine does not approve of my choice for square. I did pick an odd 1, but because the Turing Machine does not agree with that, it's informing us that square should actually be even. So let's go ahead and type that up in our notes. In section B. And we'll state that square is an even digit. And since it is even, let's go ahead and cross out the 3 odds. Okay. I think the next thing I'd like to test is criteria card E. Okay, so the Turing Machine does approve of my proposal 314. Recall that in criteria card E, we are defining the ratio of even to odds. In my proposal, I have 2 odds to a single even, and since the Turing machine approves of that, it's true, there should be less even than odds. So let's go ahead and type that up in our notes in section E, and we'll state that there are less even than odds. Now recall that from criteria card B, we established squared to be even. So this majority of odds means that triangle and circle are odd. So let's go ahead and cross out the evens in both triangle and circle. So essentially what we're looking for is a 3-digit code that is odd, even, odd. Okay. What's next? Let's see. Let me take a chance to perhaps maybe we can deduce criteria card F. And typically when we have criteria cards, for instance, like D, where we're comparing 2 digits. Now, let me think about this. So typically, if we say that a code may be in an ascending order, again, that means that they are increasing. So if they're increasing, they'd be basically taking this sort of path, this diagonal. And if they were increasing, we would absolutely know that square must be smaller than circle. And because each card needs to be, useful, if we know that the code is ascending, we would already know the behavior of square and circle, making this card irrelevant. And similarly, if we were to say the code is descending, meaning that they are decreasing, basically following this path, this diagonal, we would then know that square would be greater than circle, again making this criteria card irrelevant. So we would know by default that the solution should have no order. So I'm going to type it up as we're going to deduce that the solution has no order. Okay. And of course we already know, since square is even and circle is odd, we know it cannot be equal to each other. So basically we have it down to a 50-50 between square being less than circle or square being greater than circle. Let's see. Trying to figure out. There's nothing in the puzzle that states you couldn't have any kind of doubles, whether they're being 3 or not. So I think even though I have criteria card, my proposal, I've got a triangle 3. We do have 3 options. Let's get one of them out of the way. Let's see. Let's go ahead and test criteria card A. Oh, wow. So we got very lucky. We have established that triangle is actually equal to 3. That's very helpful. So let's go ahead and type that up in our notes, and we'll say that triangle is equal to 3. So let's go ahead and cross out the 1 and the 5. So we already know that triangle is equal to 3. Okay, well, that does it for this round. We have completed our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So recall that we did not test criteria card C, establishing how many 3s. Well, we already know that there aren't, it can't be no 3s. and it can't be 3 3s. So it's either 1 or 2. We've already established triangle to be a 3. So it's either 1 or 2. We concluded that criteria card D is now a 50-50. We know they can't be equal. And we outright deduced criteria card F having no order. So let's take a look at our possibilities. So the good thing is we start off with a 3. So it's either going to be a 2, and then because of no order, it's either going to be a 3 or a 5. Or similarly, it's going to be a 3, 4, and then a 1 and a 3. So let's see. Are there any ambiguous solutions? Well, we also have, recall criteria card D. What order is it going to be? So if it's 3, 2, it's got to be bigger. Can't be smaller because that'd be descending. And if it's 3, 4, it's got to be, square has to be greater. So if it's 3, 2, square is less. If it's 3, 4, it's greater. So that's our sort of 50-50. And then we have how many 3s are there. So yeah, it seems like it's just, two 50-50. So I don't think it really matters which way it goes. So I'm going to say 3, 2, 5 and see where that takes us. So before we start, let's just confirm, yes, that first digit is 3. That middle digit is even, and we have more odds, and it does exhibit no order. It decreases, then increases. Well, let's give that a try. Okay, so let's go ahead and let's see. I don't think we can deduce either, to be honest. So let's just go ahead and test criteria card D. Okay, so it does not like my proposal. I did pick a square value that is smaller than circle, but that's not the case. Turing Machine does not approve of that. And of course, we know that it's not equal. So we're going to deduce that square should be greater than circle. So let's go ahead and type that up. And that again is in section D, and we'll say we're going to deduce that square should be greater than circle. So let's take a look. So we have square being greater than circle. And so let's see. I think we can eliminate circle 1 because, actually no, we eliminate circle 5 because if circle is 5, there's nothing larger than 5. So yeah, let's go ahead and cross out the 5. And then let's now test how many, well, let's see, could we deduce? No, we have to keep the 1 in case it's 3, 4, 1. Or 3, well, hold on. If square is to be larger than circle, yeah, we had to eliminate that 5. And 4 is bigger than 3. I think we can even eliminate the 2 in square, because the only possibility if it's 3, 2 would be a 1, and that would be descending. Wow, that's interesting. So we know it's 3, 4. Now the question is, should it be a 3, 4, 3 or a 3, 4, 1? And that's where criteria card C plays its role. So let's go ahead and test C. And yes, it approves of only a single 3. So let's go ahead and type that up, and we'll say that the solution has a single 3. So that means that since triangle is already the 3, circle cannot be 3. So it looks like our solution is 3, 4, 1. So let's go ahead and type that up. And let's go verify. So 3, 4, 1. Fantastic. Well, how did we do versus the Turing machine? Well, it is a 6 criteria card puzzle, but we only had to do 5. We outright deduced criteria card F. And so in the first round we did A, B, E, and then in the second round we did C, D. So let's go ahead and type that up. And again, that was A, B, E. A was correct, B was incorrect, E was correct. In the second round we did the middle two. I believe C was correct and D was incorrect. And remember, we did outright deduced F. Okay, so we beat the Turing machine by 2 questions. The Turing machine took 3 rounds and queried 7 questions, and we only did it in 5. So fantastic. Well, obviously, having the recollection of how a criteria card like D, where we're comparing, I think it works for all pairings of digits, regardless if it's a triangle, square, or circle paired up with one or the other. And criteria card F, I think we can always make that argument of how an ascending and a descending behavior sort of tells us something about the ordering of those digits or the comparison of those digits. And so that was very helpful. That was one of the reasons. And I really do believe that criteria card A, getting it exactly at 3, was also very helpful. Very fortunate, very lucky. It does have 3 different possibilities, and we got it in the first try. So very fortunate. How about you? How did you solve it? And did you recall this pairing of criteria cards that helped us deduce? Have you incorporated that into your solving of these Turing machine puzzles? And if not, how else did you solve it? What criteria cards did you choose? And did you see anything that you'd like to share? Add those thoughts to the comments. If you liked the video, please do give it a thumbs up so that more people can find the channel. And of course, don't forget to hit subscribe to not miss out on any future videos. Well, until next time, have a great one.